Okay, page 47 in your notes. This is systems. And the biggest thing that you need to remember with systems is effectively that the solution that you'll be looking for is the intersection or the points where the two graphs collide. That's going to be the solution. If you were to try and solve this algebraically, you'd be subtracting one graph from both sides of the equation. If I were looking for the solution to where 2 cos x is equal to sine 1/2 x, I'd be subtracting one graph over to the other side and figuring out where they are equal to 0. So you're still finding a root, but you're finding a root of where one is equal to the other instead of where the subtraction or the difference is a 0. Having said that, it's worth saying, because it's going to be one of the possible questions that they could ask you, that the way you would read this mathematically is the height of the 2 cos x graph has a value that is higher than the height of the sine 1/2 x graph by a value of 0. It's not higher. That's the way you want to read that, and it's relevant because there are 3 different varieties of questions that they could ask you with these systems type questions, and that's one of them, is where is what graph number 1 minus graph number 2 equal to a particular value. I've got a question like that in just a minute. Now, the first thing that you're going to do is you're going to take these two graphs and you're going to graph them. You're going to use the AFP method. Because I want to save time, I'm just going to throw the graphs up on paper because I can. And I know that the 2 cos x graph is going to be your basic cos x graph, but with an amplitude of 2. So it's going to start high, go to 0, then go low, back to 0, and back high. So this is my 2 cos x graph. Looks like this. When you have two graphs on the same sheet of paper, it's worth labeling them. The sine 1/2 x graph is going to be a regular sine graph, but I'm only going to see the first half of it. So it's going to start at 0, go to its highest point, and then go back to 0. So this is my sine 1/2 x graph. And I've color-coded them so you can tell them apart by naming red as the 2 cos x graph and blue as the sine 1/2 x graph. As I said last block, when you're doing the AFP method, you will always show me AFP and I. You should have done that for at least the third graph on your quiz. I hope you did, because that was worth hefty points, not just the graph. But for our purposes, I just want to show you how to deal with these solutions. So has everybody copied these two graphs the way I just drew them? Okay, here are the 3 questions that they could ask you. They could ask you, now you don't have these on your notes, but I just wanted to kind of give you a foreshadowing into what you might see. They could ask you to find, I'm going to do this first one right here. This is the easiest variety of question that they could ask you, and it's how many values of x satisfy the blue graph is equal to the red graph. Essentially, what are they asking you? How many times do they cross each other? That answer would be a 2. Does anybody not know where I got that from? So if they say how many, I'm just counting intersections. You had at least one question like that. I believe it was number 9 on last block's homework, 9C. And that answer should have been a 4. Good so far with that question? The next variety of question that they could ask you is, okay, so what are those values? And to do that, you could solve this algebraically without a calculator, but it's much easier with a calculator. If you were on your calculator, you would just second calc 5, and then get Spider-Man on top of this intersection and enter, enter, enter. And then you do it a second time. Second calc 5, get Spider-Man on top of this intersection, and enter, enter, enter. The y value is not your answer. It is the entire point. The entire coordinate point is your answer. If they asked you for the x coordinate or the x value where that intersection happens, then it's just the x. Are we okay with that question? The hardest question they could ask you is this first one, and the reason I highlighted it ahead of time is because you need to be able to know how to read that question. To read that question effectively, you have to be able to say, the blue graph is higher than the red graph by a distance of 3. So I'm looking for a height of 3 where the blue graph is higher. Now it's important to notice that the blue graph came first in my question because this blue graph right here has to be on top. So I'm only talking about this section in here. That's the only place where that blue graph is on top. Does that make sense? Subtraction is difference or distance between. And as long as this answer that they gave me was a positive number, it means that the first graph was the higher one. So I'm looking for a place in this pink's width where the blue graph was higher than the red graph by a height or a difference or a distance of 3. And that answer becomes right here. Can you see that distance of 3 going on right there? There's 1, there's 2, there's 3. Do you see it? So what does that make my answer? Pi. That happens at pi. The blue graph is higher than the red graph by 3 at pi. Now just to make sure you got this, let me try a different question for you. What if I said 2 cos x minus sine 1/2 x equals 2? 2 answers there. 0 and 2 pi. Do you see it? The cos graph comes first and is higher. That means the red graph has to be on top. And that height difference has to be a 2. Did I see it? Jordan.
So you could go back to the other equation and make it -3. Or like, wait.
You mean if I moved these to the other side and moved 3 to the other side?
Didn't you say it could be a negative number?
It can be a negative number. I could have written this one, same equation, I would have gotten the same exact answers as where is sine 1/2 x minus 2 cos x equal to -2. Meaning the sine graph is higher than the cosine graph by a value of -2. It's not higher. So it'd be the same answers. That's the same exact question. And if you look at it algebraically, it's the same exact equation. I've just kind of moved things around. Does that make sense? Dante.
Would you have to put those answers in brackets, or could they just be...
Pi would just be the answer. You could put it in brackets, but or sorry, 0 and 2 pi. You could put it in brackets. That's not my focus. My focus is you can figure out by reading the equation where that happens. When you have to do both a horizontal and a vertical shift, things get a little bit tricky. I would encourage you before you move anything to label your x-axis before you put in any new axes. And the reason for that is because you always want to label on the real x-axis the real values. And this one is asking me to graph from -2 pi to 2 pi. So I have to label all the way across. And again, it's every 3 boxes you're putting in a pi over 2 or a half pi. Every 3 boxes is a quadrant. And now I'm going to move my axes. A -3 makes a midline of y equals -3. And it essentially moves my x-axis down 3 units. This is my y equals -3. A minus pi over 6 is going to effectively move my y-axis right 1 box. Pi over 6 is 1 box. And I will name that as x equals pi over 6. Now, for my purposes, everything else I do should be the same, but what I'm going to do is treat this like it's my origin, and I'm going to work from there. I have to fill in this entire piece of graph paper, and I'm going to do it with an amplitude of -2. Do I write -2? Just 2. Just in question.
Yeah, if you have a negative pi over 6, wouldn't the negative 3 be a pi over 2 instead of saying 3 in the
My up-down axis
Oh,
counts
it's
is a real number count. It's the x-axis that I'm counting in radians. The y-axis is actually counting in real numbers. So no, good question though. Do you understand where I'm getting
Yeah, I
at?
get it.
Okay. So my amplitude is a 2. My frequency is still the number in front of theta, which is a 1/2. And that makes my period 4 pi. And that's the reason they're asking you to graph from -2 pi to +2 pi. You are going to see one full graph here. My interval is this thing divided by 4, or just a pi. And again, I'm starting at my fake origin and following a pattern of, this is negative here, so 0, low, 0, high, 0. Does everybody know why I'm going low first? Okay, starting at the fake origin, going right pi units. Pi units is 6 boxes, so I don't want to go right to here. I want to go right 6 boxes from here. 1, 2, 3, 4, 5, 6. And then I'm going to go low, down 2 units. Right pi, back to 0. Now I'm off the grid. So when I go to connect these, will I actually hit that point? No, but I put it there to give me a where am I headed point. Do you remember doing that last block? Okay, now I'm going to backfill. This was 0, low, 0. Where am I going? 0, low, 0. Backfilling, I'm going high. That'll be here. And then 6 boxes left of that, I'll hit 0 again, and then I'm just going to continue with my graph. That is what my -2 sine of theta over 2 minus pi over 6 minus 3 graph looks like